Hi, everyone. Welcome to our webinar for Aria. My name is Michael Giardina. I'm the product manager for Acclaim Lighting. And Blaine like to do a little intro for the rest of us here.
Oh, we just met Michael. So thank you all for joining us today on our first webinar on Aria wireless, our Aria wireless system and UDM adapter. Today's hosts are going to be Michael Giardina, our product development manager, as well as John Thobe, our West Coast regional sales manager. So wherever you're calling in from, good morning, good afternoon, good evening, and Michael, take it away.
All right. Oops, sorry.
Yeah, actually, before Michael starts, if I could just say something too, Blaine.
Sure.
My name's Lauder. I'm the Director of Sales and Marketing for Acclaim Lighting. I want to just thank everybody for taking the time to join us today. Obviously, probably most of you are at home. Some of us are, as you can see, and some of us are still working in the office. Acclaim is open for business with a limited staff right now, but we are doing our thing and trying to do our best to support our customers. And obviously we want everybody to stay safe, stay healthy, and make sure that we all move past this crisis that we're all in around the world. So I know there's people on this call today from all around the world. So again, thank you. We appreciate you, and we look forward to working with you on your future projects.
All right, and so we want to note that we want you to send any questions you have during the presentation to the Q&A tab, the module there. We'll try and get to as many of those as we can as we go. We'll get started. So the first section, we're going to discuss some of the fundamentals of the system that are crucial for a general understanding of how Aria works. So first and foremost, Aria is a wireless lighting control system that we developed, which maximizes the flexibility of routing and delivery of control to commercial lighting fixtures. The backbone of Aria is a combination of the 512 DMX standard as its primary protocol, as well as a custom wireless chipset we created in partnership with Synapse Wireless. DMX was popularized by the entertainment lighting industry, but has many practical applications for commercial lighting. Some of the key benefits include the ability to transmit up to 512 simultaneous control channels at a much higher speed than other control protocols, and the ability to give fixtures unique identifying addresses for easy individual control. Because DMX 512 is an open standard available to all fixture manufacturers, Aria can be used with any third-party controllers and fixtures that utilize DMX. Aria uses a star topology to prioritize speed and accurate signal delivery. Star topology is the same as a wired or wireless computer network where all devices connect to the central access point. In an Aria system, the central point is the main system transmitter. We'll dig into a system layout in more detail, but for now, know that an Aria system can be comprised of transceivers, range extenders, and Acclaim direct connect fixtures such as the Dynadrum series. The maximum range between a transmitter and receiver is 2,600 feet line of sight. Line of sight requires that both antennas see each other with no objects in between them. When adding in range extenders to your system, you can extend the line of sight range to over 10,000 feet or nearly 2 miles. So if we look at this diagram here, we have the DMX coming into the Aria transmitter, and that's going to be from any third-party or first-party DMX controller, and it uses a standard DMX protocol. And then it's going to packetize those signals and transmit it to our receiver, which again can be up to 2,600 feet away. And so that DMX line out will feed either your fixtures or another device. When you introduce walls and obstructions between the Aria signal, the transmission range is reduced to 300 feet. Obstructions include any material that is placed in front of the antenna, which on a smaller scale can mean metal and conduit, enclosures, and pipe. So we need to watch out for all of those elements when you're installing the system. Larger structures such as reinforced concrete HVAC units and even larger brew kettles can completely block the signal. And we can work on some ways that we might be able to work around that with range extenders going forward. So an Aria system size can be up to 250 devices. Those devices, as I mentioned, can include our transceiver, our main unit, an Aria direct connect fixture, or a range extender. It encompasses all units set to any available wireless channels. So while the system has no theoretical limit, keeping it to 250 devices ensures proper transmission and signal reliability.
I want to jump in there, Michael. What Michael means by 250 devices is any device that is connected to the Aria protocol, whether it's a transmitter, a receiver, or a fixture that has the native capability. For example, you could say maybe have one fixture on a pole that functions as a receiver. That's one of your 250 units, but you could use the line of DMX out from that fixture and connect 4 other fixtures on that same particular pole. But only one of those devices counts as one of the 250. So that's something to keep in mind, especially with fixtures that aren't native with the Aria. Say, for example, you've got a receiver bringing signal into a locality, but then we've got a number of fixtures wired off of that one receiver that counts as one of the 250 devices.
Okay, and we have a question here about, is there a rule of thumb on the number of walls? No, but I will say the more impediments you put between the receivers and the transmitter, the more it's going to knock down that signal. So we have to account for that. And when we go through how we set up our system, there's ways we can get around that, even in very short distances with the range extender. Okay, let's move on here. The 200, sorry, we have one other question here. Is the 250 devices wireless or a combination of wireless and wired? That is only on the wireless network. So once you break out of the wireless network from standard DMX to wired DMX, you can go down your normal runs of 32 devices and a normal DMX run from there. All right. So a bit more of the, a couple more notes on the more technical details of the system. Aria runs on the industrial, scientific, and medical band, or ISM, and that's at 2.4 gigahertz to 2.5 gigahertz. It's the same range as most residential and commercial Wi-Fi systems. We'll be discussing how we navigate that with wireless traffic in a bit more detail soon. Aria transmissions are protected via the Advanced Encryption Standard, or AES. AES was developed by the National Institute of Standards and Technology to be the definitive encryption system for electronic data. While there is not sensitive material in our Aria transmissions, the encryption provides an extra layer of protection from system hacking by preventing the source signal and packet information from being identified or examined. So as we go here, we'd like to present a few projects that we have used Aria in over the years. We currently estimate there's about 500 projects in the US alone using Aria on a daily basis. Kingston City Hall in Kingston, Ontario, revamped the entirety of their exterior lighting in 2019 for this historic building and the market square that's just outside of it. One of the key challenges was how to get to the control to the Springer Market Square right outside that capital. Aria allowed for the control signal to be sent remotely from the main building to the myriad of Acclaim fixtures in the project, including Dynadrum, Aquadrum, and Dynagrace DMX. Directional antennas were also employed in the system from the main building to the square.
This is a perfect example of where Aria is a great system for renovation. This is a historic building. They've got beautiful landscaping, pathways, public egress, and they want to light a feature on that market square. So there's existing power infrastructure in place. You know, most fixtures that Acclaim uses the Aria system, it's universal 120, 277 AC. So they're able to install control within the building and then use the Aria system to bring that control to the central square without doing any new infrastructure construction, laying any new conduits, or running those DMX wires. Great application.
Yeah, and to his note there, one of its main benefits is eliminating the need for that costly infrastructure in historic and heritage-focused buildings. We'd also like to note here that while Aria is capable of handling many advanced applications, whenever a wired DMX system can be implemented, it's always the preferred method. It's perfect for applications where wires can be pulled to some or all fixtures, and particularly useful in retrofit applications.
I mean, what that means is if we're doing ground up new construction and you want to run an advanced DMX control system, you know, there is an argument to be made for just running the wires and foregoing the use of a wireless system. But in these applications where running the wire is a serious impediment to completing the job, wireless is a great solution.
We have one question that I'd like to touch on, which is what about signal latency? Are there delays on sending and receiving the signal? Aria has no latency. It has a very minimal latency. It's almost imperceptible as long as the system is configured correctly. That was part of our arrangement with Synapse, is that they had to repackage. They already had a lighting control system that was wireless, but it was designed for really long range and slow transmission. So our partnership with them was in implementing DMX and implementing it at the required speed that would be the same as a wired system. Now, our system may not be able to transmit quite as far as theirs, but we're able to give the DMX system the proper speed that it needs to run even a really dynamic show with tons of DMX channels running at the same time. So that's the answer to that one.
Yeah, and we're going to get into fixtures a little bit later. Fixtures do not act as repeaters. All Acclaim fixtures with built-in Aria will function as a receiver only. So my pole analogy earlier, one fixture on the pole can be a receiver. It's one of 250 devices, but you can wire the DMX out from that fixture to other product fixtures in series of the 32 for DMX.
All right, so now we'll discuss some of the different components that make up the Aria system. So first is the transceiver. The transceiver is the primary device in an Aria system. And John's gonna hold one up for you there, maybe. And it's IP66, which allows it for wet location placement, which essentially means you can place it outside of an enclosure without any issues. Those cables will go into an enclosure. We'll talk about that in a sec, but the device itself can either live inside or outside an enclosure without any additional components. So what's in the box when you get an Aria system, a transceiver? You get the main box supplied with 4-foot power cords and DMX cords. You get the 5 dB directional omnidirectional antenna, a 9-foot extension cable for the antenna, and our Type N adapter, which allows it to be connected directly to the body. So you can assemble it in one of two ways. On the underside of the Aria transceiver, there are two 4-foot fixed cords, one for the power input and one for the DMX in and out. There's also a moisture-proof air vent and the Type N antenna port. You have the choice of connecting Aria directly, the antenna directly to the main transceiver body with the included adapter, or using the 9-foot cable to place the antenna farther from the transceiver. You should not extend the included cable any more than the 9 feet or use alternate cables, as they may degrade the signal quality and are not covered under a warranty. So the one that John has there is with our Type N adapter. So that's a direct connection. The one thing to note about the antennas is you want to place them vertically. So whether it's pointing down or whether it's pointing up, it just has to be vertical. It doesn't have, we don't want it horizontal in any way, shape, or form. So that'll maximize your signal strength.
Oh, and I do want to touch on this because this is a very common question that we get once these things are in the field. These are basically like a coax style twist and lock connector. So that cable format is familiar. It's very important that once you get to this box, this device, you're only using the components that we supply in the box. The cable extension from base unit to the antenna stick is limited because that depreciation in signal is a real it goes exponentially down if the cable is extended.
Okay, moving on to the transceiver, the cables themselves. So we have the AC input cable, and that's 100 to 277 volt. It actually runs 100 to 240, and then there's a tap for 277, but 277 volt is fine as a direct connection. A note on the input and output wires, that is how the transceiver knows whether it's a transmitter or a receiver. It's based on how you wire it. So if you wire up the DMX input, the transceiver will automatically become a transmitter. If you wire up the DMX output, it will become a receiver. All cables are bare wire, and they're designed to be installed in standard junction boxes.
Yeah, I mean, that's a really simple format. I mean, it's a single device, and it's auto sensing, right? So you cap the DMX out wires, wire for DMX in, it's now a transmitter, and the opposite is true to make the unit a receiver. Cap the DMX in wires and wire DMX out to the fixtures, and it's auto sensing. It's an auto sensing transceiver.
Hey, Mike, real quick before you continue, there's a couple of questions in the Q&A. I just want to confirm, are we going to answer those questions to everyone at the end? Because some of the questions will be covered in the presentation.
Yeah, we're kind of going through and answering them, ones we think are appropriate to the section as we go, and we can definitely get back to everyone kind of toward the end of it, for sure.
Great, thanks.
Okay. So talking more about the transceiver here, you can select any of the 15 available wireless channels right on the display. The 2-digit display will automatically shut off and lock after 10 seconds. So you can unlock the unit by holding down both the up and the down buttons at the same time. The red LED is lit when the transceiver has been wired to a transmitter and is receiving DMX. The green LED is lit when it's wired up as a receiver, paired with the same wireless channel as the transmitter. When operating as a receiver, the bars of the radio signal strength will show you how strong your signal is in the current location. If the receiver is receiving less than 2 bars, placement may need to be revised, or the range extenders may need to be added to the system. So that signal strength is a key metric there when you're setting up your system. You can even take units out before you install them and see what your signal strength is from unit to unit on the device itself. And we'll talk about what to do about how to arrange a spectrum analysis in a minute, but just know that you can do that right off the box itself to get an idea of how well that signal is being received from a transmitter to a receiver.
Just kind of in action there. You can kind of see how the menu goes. And press and hold, and now I'm able to scroll and change my channel. And that's as easy as that's all it takes to set the wireless transmission zone or the receiver channel.
All right. We have a couple questions about ambient temp for the device, and I believe it's -40 to +50 Celsius.
That's ambient air temp for operation.
Right. So some notes on placement. We did kind of touch on this a little bit before, but here's a little bit of a detailed view of what we're trying to avoid when we're installing Aria. Your choice of installation, particularly their antennas, have a significant effect on the range and speed of the communication. As we mentioned before, line of sight is always desired, which is a clear path between those 2 antennas. So you want to make sure to try and keep clear of any metal and keep at least 3 inches from surfaces whenever possible. All that said, Aria can certainly work in less than ideal conditions. It just may require some adaptation and testing to determine the right mix of system components and placement. But you see here some common things like avoiding conduit, not placing the antenna in the enclosure, and that's why we give you the 9-foot cable. So if you needed to mount the transceiver and connections inside an enclosure, you could simply use a conduit knockout to go out of the unit, out of the enclosure, and mount the antenna on the outside of the box. So the antenna is still outdoor rated.
Very important here. The outdoor, this is outdoor rated. The 5 dB antenna is outdoor rated. These cables feeding into this unit are outdoor rated. None of this equipment should be buried in a box, especially the antenna stick itself. If it gets put into a metal enclosure, the system will not function correctly. So getting this thing away from obstructions and metal especially is really going to be a benefit to making sure the system is fully functional and works great. Mikey, you had answered a plastic enclosure, but I don't think we'd want to use any enclosure. We'd want the stick to be exposed. So the answer would be
for the antenna, the same rules apply, because the assumption is that would still be 3 inches from the antenna. And we really want to try and keep that as clear as possible. But if we can avoid any impediments for the antenna, that's ideal. Yeah. There's no reason to keep it in an enclosure, plastic or metal otherwise, just because it's already outdoor rated and you'll get the best signal with it being outside. So one additional system component that's particularly useful for the transceiver is the optional directional antenna. The standard antenna is omnidirectional. It works best in most applications, but if you need a bit more signal strength in a single direction, you can add this to any transmitting or receiving unit. It's a pole mount design and can increase signal strength up to 50% in a single direction. And also increases range up to 25% in a desired direction. So it really is more about improving that signal strength. If you look at the diagrams, where normally our omnidirectional would cover that in an equal oval, circular pattern, the directional antenna will focus that signal strength. So it's not necessarily getting you a ton more range going in one direction. What it is doing is boosting that signal in that single location, in that single direction.
And Michael, you and I talked about this a little bit briefly when we were preparing this. You wouldn't use the omnidirectional as both a transmitting antenna and a receiving antenna. At that point, we're talking about other devices. So the omnidirectional antenna, think of like that Kingston City Hall. We want to point, maybe we want extra signal boost directly from the building directly to a receiver at that square. That's where the omnidirectional antenna comes into play. It allows you to really expand the line of sight with a little bit more punch, typically from a transmitting perspective.
Yeah, that's correct. I'm just reading a question here.
You don't want to use two of the, you want the directional antenna to be a transmitting source, not necessarily be used as a receiving source.
All right. So next up in our system components is the range extender. So the range extender is used to expand the system range and get signal to hard to reach locations. The body is essentially the same as the transceiver. It's IP66 and all the components are more or less the same, but we're going to go through them here just to cover it real quick. You get the exact same items that you do in the box that you do with the transceiver. That includes the omnidirectional antenna and the extension cable to get that antenna outside the enclosure. The connections on the range extender are similar to the transceiver with the exception of the DMX cable. There's no DMX cable on the range extender because it simply grabs the signal from a transmitter and rebroadcasts it to a receiver. So there's no reason to get DMX in or out of the range extender. You have the power input, the antenna input, and the air valve. Here again, you have the choice of connecting the antenna directly to the main transceiver body with the included adapter or the supplied 9-foot cable. And the same notes here apply about not using third-party cables or extending the 9-foot cable as that could ruin the signal quality. Looking at the wiring for this, we just have the multi-voltage auto switching input for power, and all cables are bare wire again. You can install them in standard junction boxes.
Basically, like this. No DMX cable.
All right. So talking about the control panel on the range extender, it's exactly the same as the transmitter, the transceiver, But the one thing to note is that the green and the red indicators will act more like a receiver than they will a transmitter. So they're going to tell you, I'm receiving the signal, and then it's going to have a signal strength menu is going to show the signal strength. So you know, if I'm placing that range extender X feet away, I'm actually getting 3 bars of signal, and that's going to be sufficient for this project. So you can still use it in the same way you could a normal receiver to determine placement. And again, the same antenna placement rules apply to the range extender. So we want to keep line of sight when possible, mount away from objects. So let's talk a little bit about the direct connect fixtures. Direct connect fixtures are units in the Acclaim line that have an Aria receiver built in directly to them. They have been included at no extra cost since 2014 when they were introduced with the Dynadrum series. And now we've expanded that to several units in the Acclaim line. The benefit of a direct connect fixture is that it can join an Aria system without the need for another transceiver unit on the receiving side. So essentially it can just grab signal right from the transmitter. Here are the current Acclaim direct connect fixtures, which include 5 different output levels for outdoor floodlights and our new high ceiling downlight cylinder 1. All of these units have the ability to disable the wireless radio and select your wireless channel. For the Dynadrum series and the Dyna Accent Gen 2, which is going to be out soon, you can adjust these settings either on the onboard control display. There you go, John, showing the Dynadrum EO display. Or you can choose to set it via RDM, which is over the DMX line. You can use our XMT350 tool to set the address, a wireless address, turn the radio off and on using RDM. The Dyna Accent Mini and Cylinder 1 both change these settings only via RDM because they don't have onboard displays. And with the exception of Cylinder 1, all of these fixtures are available in single color white and color changing variants.
So the photo there shows the nice family in white, and you can see that we're offering a range of output options, from large to like a small accent fixture, for landscape. So there's a scalable system, and we're using the Aria format across the fixtures, so you can really get a full format to do different ranges of applications within the same project.
I'm going to go back real quick to a couple of questions we had on the receiver transmitter stuff.
Sure.
And one question was, can a receiver transmitter be set to be a repeater if a DMX cable is not wired to anything? And that is no, it cannot. So they are dedicated units. The reason for that is because the range extender has to get permission from the transmitter to do the signal hopping. So we have to have a separate device that has slightly different software in it to do that. So a transmitter receiver is only a transmitter or receiver. A range extender is a separate unit only. And then there were 2 questions here regarding RGM over Aria. Right now, we don't support RGM over Aria, but this is something that we are currently in development for a next generation of Aria. But that's a great question. All right. So let's talk a little bit about UDMW. So UDMW is part of our universal dimming series, but it's a little unique in that it has the Aria receiver built directly into it. So it receives a signal from a transmitter and then can convert it to 0 to 10 or AC dimming. The AC dimming is compatible with both forward and reverse phase dimmers, and it allows for traditional 0 to 10 or line voltage dimming systems to join the Aria network. The maximum load for a UDM is 1,000 watts, so you can operate a significant number of fixtures if they're line voltage dimming on a single unit. You can also adjust the wireless settings on UDMW with the onboard dip switches or RDM over the DMX line. So UDMW is a key tool if you're trying to integrate with different systems with different control mechanisms. So even our Linear 1, for example, could take a wireless, which is a 0 to 10 volt unit, could take a wireless signal from Aria and dim our Linear 1 fixtures with 0 to 10. Seeing UDMW as a wireless hub is another way to look at it. the other thing that it does is it transmits all three of those protocols, so the phase dimming, the 0 to 10 volt dimming, and the DMX simultaneously. So it can receive that signal from the transmitter, and then inside the UDMW, that control signal converts all three outputs, all three output protocols simultaneously. So in that sense, you could theoretically control a 0 to 10 volt fixture, an AC dimming fixture, and a DMX fixture, which theoretically would be a white light single color fixture, all together in the same system. Now, one thing to note is all of those fixtures would be grouped together. So there's no individual control there, but as a whole, you can dim them all up and down as one system.
What this is a tool for is integrating fixtures that are not native DMX, but bringing those under the same control umbrella. It's really the UDMW is really a controls integration tool, and with the wireless component, it allows you to do controls integration on fixtures that are not DMX native, and bring them into the wireless control umbrella.
And a couple questions. Can any RDM device set these parameters on the UDMW and also the other direct connect fixtures? Is it proprietary? It is not. It is standard RDM and can be used with any RDM console or device. And can AC dimming be set to switch to non-dim? It can. So you can pass through the AC if you want from the UDMW, so you don't have to use the AC dimming. It is switchable on the device. Okay. So the last component we're going to talk about here is our Canvas controller. Canvas is a kind of nice hybrid of DMX and 0 to 10 in a single wall mount unit. And it has a built-in Aria transmitter that can be a starting point for a larger Aria system. Because it's mounted in wall, the first transmission is limited to 300 feet, but you can use a range extender to take it from there and expand it to the full 2,600 feet. So that antenna is just behind that panel, that white panel on the Aria. And you can send signal right from this device to any fixture or Aria device without wires. So theoretically, you could have AC power plugged into this, AC power plugged into fixtures, and this could directly control it without a single DMX wire. It's a great way to get a control system running. If it's difficult to pull wires to a control location, you could then start your system from Canvas and boost it to a normal size system. Or it's just convenient for smaller rooms and systems. You could have a Canvas in a single room controlling multiple fixtures that, that you could use within that room.
Yeah, I think we had a question earlier about how many walls can you transmit through. I think this is a good time to talk about that. So if the Canvas controller is in an electrical control room or a central building within an office space, and you're going through multiple layers of interior walls that have wiring, maybe metal stud work, and exterior walls, maybe it's concrete blocks or a steel structural system, and then we're expecting to pick up that signal on the exterior of the building and transmit to fixtures, and that's kind of a big call. I like to think of this using the internal transmitter. Maybe we've done a patio extension where we have some interior space and we've got a new lighting network outside. That's a great place. Throw one of these in the wall, use its native transmitter, pick up an outdoor range extender, and just layer the ground with fixtures on the wireless system. Awesome application. If we're going from kind of a central location inside a building to exterior fixtures, we typically recommend that you would run a control wire to an exterior transmitter. So again, trying to keep the system as line of sight as possible. From transmitting antenna to receiving fixture or receiving antenna.
So another case study here. Radio Flyer headquarters in Chicago used Aria when they had space considerations with an inability to run control wiring inside the facade. So they looked to new control options for that. Antenna placement is crucial in applications like these because there's so much surface structure in and around the fixtures. So essentially what we did is they mounted mounted the Aria transmitters or receiver transmitters as close to the facade as possible and ran that 9-foot cable through. So the antenna sits right in that small section of the facade, and the fixtures are in there as well. So it's talking to them kind of in a direct view application from top to bottom on the facade. And this was using our Dynadrum HOs with Aria. So now we're going to look at various ways you can configure a system based on the needs of a project. The simplest system configuration is a transmitter to receiver setup. You can connect any DMX controller to any DMX light and transmit up to 2,600 feet when you're using that line of sight range. You need to configure the setup. All you need to configure the setup once it's installed is match the wireless channels on the control displays, and all the units will automatically connect. No other steps are needed from the end user. And Aria systems are limited to that 250 devices that we mentioned before. So in theory, with this basic configuration, you could have one transmitter and 249 receivers on a single channel.
Or with the 250 devices, one transmitter, 249 unique fixtures that are receiving the wireless signal.
So Aria is capable, when we talk about multiple universes. So if you're not familiar with what a universe is how DMX is packaged in groups of 512 channels. So a lot of times you'll have a controller or a system that will say, I have 2 universes, and that means it has over 1,000 available control channels. Aria is capable of transmitting multiple universes of DMX. When setting up the devices for multiple universes, you need to give each unit its own wireless channel. And then they must be at least 2 numbers apart from each other. So in the example here, we're transmitting 3 DMX universes on channels 2, 4, and 6. The 250 device limitation is across all universes. So you would need to divide up your system accordingly between those 3 universes. The wireless channels you select do not need to be sequential in the way that we have them here. We'll show you why in the next slide in terms of moving your system around the wireless traffic. But just know that you can do up to 8 universes simultaneously this way. It also depends on the system location and would require some optimization on the signal side. And I think we had a question earlier. We're talking about one universe. Yeah, so a point-to-point system, when we're talking about wireless channel 2 to wireless channel 2, that is a one universe system. But then you can simply use a second universe on another channel that's spread. We mentioned those two numbers apart, essentially, on the wireless channel. So we're going to talk about optimizing signal strength using channel selection. And this is the first and almost always the best tool other than the range extender for optimizing signal strength. So Aria uses the same radio band as most Wi-Fi systems, which runs from 2.4 to 2.5 gigahertz. So when Wi-Fi access points are near, Wi-Fi can cause interference along with other radio traffic on this band. If you can see here, Wi-Fi uses channels which are 22 megahertz wide, so they're really big and they're in overlapping increments. The most popular channels that device manufacturers use are 1, 6, and 11 because they maximize distance from each other. So if you look at that graph, you can see where 1, 6, and 11 are, and it gives you enough space to control, to use 3 different wireless channels in a building and not really have them overlap at all. So knowing this information allows you to prepare an Aria system for proper adjustment on the 2.4 gigahertz band. We do highly recommend doing a spectrum analysis on site to know precisely where signal problems may arise. And that will give you a feel of where signal is heavy, where signal is not heavy. So you can place Aria in those gaps. So what Aria uses is a slightly different standard than Wi-Fi does. It's still on that same 2.0 gigahertz band, but the standard uses 3 megahertz with channels. So if you look at that graph, you can compare how wide 1, 6, and 11 are to each of our Aria radio channels. And so we can identify those gaps for placement just as a good starting point based on that. Now note that Aria channels will most always overlap depending on where they are. So that's why, again, doing a spectrum analysis can tell you where you're heavy and where you're not in traffic. But the notable exceptions, again, there are channels 4, 9, and 14. So those are always a good starting point when selecting your wireless channels on site, because they will often carry less Wi-Fi traffic or local traffic.
So this is kind of like the default scenario, like, hey, I'm going to transmit wireless to a facade of fixtures. What channel should I set it on? Well, the easiest default is go to Aria 4, 9, or 14 to do that, to do those base level installations.
Now, if you had a system, a Wi-Fi system that was running directly on one of those channels, you can easily just adjust right on the device to say, okay, I'm going to move to 0 now. And you can see that signal strength bar adjust accordingly as well. So the signal strength bar will tell you, hey, this channel may be better than this channel. So it's a quick visual way to also make that adjustment. But, you know, recommendation, you can always start on those 3 channels. So let's talk about using the range extender in conjunction with the system. So there's a couple of main objectives with the range extender. The first, maybe obviously, is extending the range. So dropping the range extender between a transmitter and receiver can essentially double the line of sight distance. And in a range extender setup, it's as simple as, again, matching that wireless channel to the transmitter, and the units will automatically communicate. And you can jump, it'll automatically make that jump from transmitter to receiver and boost that signal. So there's no other setup needed other than to make sure your wireless channels are lined up.
This guy, very important.
So objective 1A can be viewed related to 1 in that not only can we extend the system, but we can expand it. So you can use up to 5 range extenders in series, and this can expand the total range up to 13,000 feet. Now that's obviously an optimal line of sight application. And each extender can feed signal to the receivers, the direct connect fixtures, or a UDMW. So if you look in this diagram, you can see that each extender has its own little bubble of fixtures or receivers that it can communicate to. So each of those uses its omnidirectional antenna to create a new bubble of signal and then still rebroadcast it to another bubble. And you can do that up to 5 times. So that's really an effective way to go long distances and keep the system integrity going.
Think of this diagram as the long and skinny sight, where you have to start the transmission or base your control at one end of that long and skinny sight. I think even looking at the diagram, it shows kind of a zigzag pattern. Think of that stretched out more like a stretch slinky, like something where you're really going, you know, in a long linear direction where you're able to repeat the signal down that line and really extend the length of coverage using the range extenders.
We do have one question. Is there a way to test out the signal strength during the design process prior to purchasing to determine if the extenders are needed? I would say contact us for that. We're happy to get involved even in the design process to make sure that the system is working for the environment. It's as important to us as it is to you. So definitely get in contact with our team to do that. We can probably get samples. We can make that work on a case-by-case basis, obviously. So objective 2 is boosting signal in hard to reach places. So places where you need to boost signal to go through a surface, around a corner, or anywhere where line of sight isn't possible, you can use up to 5 range extenders in series for this application, and you can still use all the components in the system as long as they reside on the same wireless channel. So this is as easy as this diagram shows. I'm going around a corner and I may not get signal to that corner because the omnidirectional antenna cannot get through that double wall basically by the time you get to the other side of that corner. So adding a range extender at that corner will definitely give you signal to all areas of that wall. This also works when you're trying to go through objects, as we mentioned before. So if you do have, you know, multiple walls, multiple locations, you can put a range extender in between each of those to keep that signal boosted and strong. So it's also useful in these smaller applications where you need kind of to reroute the signal to maximize it for the installation.
Oh, and it just, I want to reiterate, we showed that line graphic earlier about N series. And when we talk about 5 range extenders in total, or 5 devices in total, that is total. So if you're going left and right, you know, you can go 2 this way and 3 this way. You don't get to go 5 and 5. That's a no. 5 total, or 5 total.
And we have a question. Do we have a site tool that we lend out to test Wi-Fi signals on site? We do have a couple of spectrum analyzers that we can lend out on occasion. We just need to make sure we get them back because they're expensive. But yeah, we can do that again on a case-by-case basis.
Contact your local sales rep.
Yeah, exactly. And finally, one more case study here, which is the Nashville International Airport. So they wanted to add a dynamic lighting system with dynadrums and Aria to the facade of their main parking structure. This was a tricky installation with a lot of wireless traffic, obviously because it's an airport, and it was a direct connect fixture. So they had signal going into a dynadrum and feeding, you know, like 10 dynadrums on a hard line from that direct connect fixture. So one thing to mention is it can act as a hub, right? So you can have a dynadrum receive the signal as a direct connect fixture, and then you can run the DMX line out and connect more fixtures from there on a hard line. So we had some signal reliability issues here initially, and we stepped in to help fine tune the system. We did a spectrum analysis, we added range extenders, and we made sure that each of those runs where it's a direct connect fixture to the other fixtures are wired properly, because there was a few that just weren't wired correctly. And so doing all of that, we had an operating system within a day. And so it's as easy as that, as trying to you know, work around a system that may not appear to be working well at first. There are methods and ways to go about making sure we can have an operating system.
So yeah, things that were essential here was testing signal to make sure we're broadcasting on the right range. Michael mentioned how multiple fixtures were wired off of single units functioning as receivers. So now we're cutting down from, you know, 100 fixtures that we have to test for wireless connectivity down to maybe 10 or so, 10 of those 250 that have to receive signal and have quality signal strength. And then we used range extenders to make sure that those important pieces were receiving the wireless DMX. And I saw a question earlier, if you want assistance from Acclaim about how to lay out the wireless system, definitely work with your local rep, your local territory agent. And for those agents out there, you can definitely work with our inside sales team. They're all trained on how the system goes together. And then also, you know, they have the best connection to Michael, our tech wizard. So that's the approach.
All right, and I think that just about covers it for us. We want to thank you for joining us. We'll go through the Q&A here and go through the list. If you still have questions, feel free to send them over there. You can email us with feedback or comments at webinar@acclaimlighting.com. And we thank you for joining us today.
Awesome. Thanks.